Good evening to you all. Welcome to Vacation e-learning class. Today we are starting with the meaning of simple machine part 2, as we did for the part 1 in the previous lesson. At the end of the lesson, you'll be able to state at least 4 types of simple machine and explain the meaning of lever and outline 4 examples of lever and class it belongs to. Starting with, we talk about machine, and we said machine is any device that help us to do work easier and faster. So now we went through the properties and we did simple calculation on it. So we are starting with the type of machines, which is the continuation of the previous lesson. There are several types of machines, but we will talk about a few, which are the lever, the pulley, inclined plane, wheel and axles, wedges and gears. But in all, the lever that will go into detail, because that is where most of our questions are being asked for, because that's where the syllabus is demanding more from us. So let's take the first one, lever. What is lever? We say it's a machine or device which enables a small force to be applied to it so that a greater force can be overcome. Or we also say that it's a simple machine who rotates at a fixed point called pivot or fulcrum. So any simple machine that rotates at a fixed point called pivot is known as lever. And it has 3 main parts. And the 3 main parts of lever are the load, the effort, and the pivot. And the position of these 3 parts, the effort, load, and the pivot, will tell you the class that particular simple machine belongs to. So NB, we say the longer the lever arm, the easier it is to do a particular work. For example, if you take something like a coin, it will be difficult for you to use a coin to open a mellow tin as compared to a spoon, because spoon is having a longer length that help you to exert a simple effort to perform the task you want it to. So let's look at the classification of lever. The first one we call the first class lever or the first order lever. As I told you earlier on, the position of the part will tell you the class it belongs to. So when we talk about the first class lever, it's a type of lever in which the pivot is between the load and the effort. The pivot is between the load and the effort, or the pivot is between the effort and the load. The emphasis is the middle one, which is the pivot, where the pivot is located. Example, we have the pincers, the crowbar, which is being used by the carpenter. We have the scissors used by the seamstress, paper cutters, pliers, spade, seesaw, and other things. So this is how the diagram look like. We have the effort, the pivot being at the center, then we have the load at the end. Let's look at the second classes of lever, which is the second class lever or the second order lever. For the second class lever, the effort, the load is between the effort and the pivot. Here the position has changed. Now the load has come into the center. So where the load is between the effort and the pivot, or the load is between the pivot and the effort, that particular device or simple machine is classified as second class labor. For example, the common device that I always use to remember second class labor is the wheelbarrow. If you take the wheelbarrow, see that the load is at the center. It's between the effort and the what? Pivot. So when you remember wheelbarrow, it must tell you that we are talking about second class labor. Then we have the nut crackers. We have the bottle opener, as we used to open our soft drinks. Then we have the steel yard. Then we have the weigh bridge. So the weigh bridge that the road, the MTT people are using to check the weight of the load of a heavy other cars. You see that they have the weigh bridge straight there, and the car will move to be at the center of it for them to take their reading. So the car is acting as a load because it's at the center where we have the supporting end, the effort, and the pivot. Let's look at the third class of labor. For the third class of the labor, the effort is between the load and the pivot, or the effort is between the pivot and the load. As I told you earlier, the effort is on the middle part. An example is the hoe that we use to weed, the cutlass. We have the screwdriver, nail clippers, others, fishing rod. They are all examples of third class levers. Please take note of them. They are very, very important that you need to know about it. The other type of machine apart from lever is called the inclined plane. The inclined plane is a plane on which a heavy load are pulled along so that smaller force is needed to raise the load through a given height. So if you take inclined plane is like what we call the disabled steps. It is something like this, and we have this edge acting as the inclined plane, and this edge from here to here is referred to as the height of it. Then from this side stretching down to the edge is what is referred to as the length of it. So example is the staircase, as I said. Then we have the ramps, we have the gunplanks, we have the road winding up mountains where we used to do the speed ramps. You see it goes up and descend down, and they are all example of what? An inclined plane. And if you take the inclined plane, it can be expressed as, in terms of mechanical advantage, are sometimes equal to the velocity ratio, and this one is right when we ignore what? Friction, and assume that the work done on the load is equal to the work done by the effort. Then we can say that the velocity ratio is equal to the mechanical advantage. And the mechanical advantage of the ratio is equal to the distance moved by the effort and the distance moved by the load. So the effort passes or make use of the length, which is the slanted part of it. So if you take the slanted part like this, that place is what is referring as the effort distance. So the length is equivalent to the effort distance, while the height here, the height at this end of the plane refer to the actual distance of the load. So that one will be the distance moved by the load. It is very useful because similar force is applied to lift a load at a greater height. It helps us to lift a load to a greater height, make it simple and straight away. It also make it easy to move heavy trucks when inclined plane is what is used. The next type of machine is called a pulley. The pulley is a simple machine involving one or more groove wheels. In pulley, load is attached to one end of the rope whilst the effort is applied to the other end, and the rope passes through the groove, and when pulled, it helps to raise the object up. Example, the pulley is used to hoist flag. So you see that the flag is tied at the other side, while the one hoisting it also will be pulling the rope at the other side. So as the pulley is turning, then the flag will also be moving to where you want, the height you want it to be. And another example is what it is used to lift water from a well. When we are lifting water from a well, they have a pulley that they turn. As they are turning, then it is pulling the water from the down to the up for the user to use. And we are having types of pulley. We have two major type of what pulley. We are having the fixed pulley and the movable pulley. The fixed pulley changes direction. It makes use of one what disc pulley or a disc device that I used to turn the load. Then the movable or the multiple one makes use of two or more hot discs. So you see that we have the load here, then we have the effort here. So as we pull the object this direction, then the load will be moving upward in the same way as we have in the movable or the multiple pulleys. In some pulley, the number of pulleys in the system is equal to the velocity ratio. We are talking about the number of discs, the turns, is equal to the velocity ratio. In some cases, it's not always the so. So if the number of pulley is y, then it means the velocity ratio will also be what? Equal to y. The velocity ratio will also equal to y. In some cases too, the velocity ratio is equal to mechanical advantage, but we will limit ourselves to only this side. Those who do the elective physics, they go into detail. But as the number of pulley increases, as you have more pulleys, then remember it affects the overall efficiency of the machine because it decreases due to what? Friction. So if you are having, especially having the multiple or the movable pulleys, they are plenty. As they are all turning, they are all overcoming friction, and friction is affecting all of them, and it affects the movement of the load or the object. So for example, determine the velocity ratio is there's no and there. Determine the velocity ratio, mechanical advantage, and the efficiency of the diagram below. And we said that the number of pulley will tell you the velocity ratio, and the load at the down here also will tell you the mechanical advantage. So now we are having two discs, two pulleys, one here, one is here, then we have two also here. The second one is also here, which is the 2. Therefore, we will see that the velocity ratio is equal to 2. And at the same time, the mechanical advantage is also equal to 2 at the down there. So 2 will be equal to the velocity ratio and the mechanical advantage. When we go to the second diagram B, we are having 3 pulleys. Therefore, the number of pulley is 3. So the velocity ratio will also be 3. And we also learned that at a point the velocity ratio is equal to the mechanical advantage. So try your hands on the C and the D, and I know you will get it there. The other type of machine, we have the wheel and axles. The wheel and axles. The wheel and axle is a simple machine consisting of a wheel of different sizes made up of a pulley and axle. It has two rims that are larger rim and the smaller rim. So we have the larger rim and the smaller rim. The larger rim is called the wheel and with bigger radius, while the smaller one is called the radius, and the smaller one is having a smaller radius, and that one is called the axle. So the bigger radium, the bigger wheel or the bigger rim is called the wheel, and the smaller rim is called the axle. Therefore, we say that the effort to move through is equal to 2 pi r, capital R, while the load is raised through the smaller I, which is all the 2 pi small r. Therefore, the small to be like 2 pi the larger rim, while the load will be 2 pi the smaller rim. So if you look at the diagram here, we are saying that the bigger rim is called the wheel, while the smaller one is called the axis. The bigger is called wheel, the smaller one is called the axis. And the velocity ratio, as we know, is equal to what? The load over effort. The load over effort. So when you come here, you will see that the bigger one, which is the wheel, is represented with the capital R with the bigger radius, while the smaller one, axle, is represented with what? The small r. So 2 pi is equivalent to 3.14. It will be given to you. So when they give you the pi, the radius, you multiply it by 3.14 times 2. Then you divide it by 2 times. So here, even this one, we'll just cancel this. And you divide this one by that straight away, then you go. So the velocity ratio is equal to this by this, whilst the mechanical advantage is equal to capital R over small r. In wheel and axle system, the load, which is the weight, is usually attached to the end of the rope, while the effort is applied at the larger part. So the load is here and the effort is also here. Let's take note of them. You need to know these basic terms about them. Then the next one is the wedge. The wedge, as we all know, we have been using it for splitting firewood in our various localities, especially those who have lived in village before. They are familiar with this. We use this thing to spread firewood. The sharper part is what make it what? The wedge. We say it consists of it's a simple machine consists of two inclined planes aligned or joined together to form a sharp edge. Example include a carpenter's chisel, as sharp end of cutlasses and hoes. So they are all example wedge. Then we have the gears. The gears are also machines that help to transmit forces or change the direction of forces to make work easier. And it is normally consists of interlocking circular discs with teeth around its edges. And as one disc turns, it transfers the force or the motion to its neighbor, which can result in change in direction of the force. And the common one, as has been used in a bicycle, we have the bigger side and the smaller one, linking the two sides. So the driving gears is the smaller one. Then this here too, we have another driving gear with 36 teeth. Then here is also the driving gear is having 9 teeth, and the driven one is having 36 teeth. For that one, we look at the number of teeth in the driven hole over the number of teeth in the driving hole will give you the velocity ratio. And the other type of machine I want you to go and read about them is the screw and the hydraulic press. Go and read about them and you understand more about it. So far, these are the common things you're supposed to know, the basic things you're supposed to know about simple machine. Yesterday we talked about the first part, and today we have talked about the last part of machine. So we have finished machine, and God permits, we will talk about the other type, which is friction, which is also part of machine. Thank you very much. Have a nice evening and enjoy the day. Bye bye.